right? 3.4, right?
Yes, the chain rule.
Continued. Example, I don't remember. Let's find the derivative, right? What was the function? Oh, sec. Okay. What was the function?
The chain rule.
There was something in parentheses, right?
Oh yeah, x cubed over x to the six plus 7.
Over x to the 6
Yes.
plus 7, like this. Is there anything on the parentheses?
S squared.
So we're gonna need a few things. We need the quotient rule. Right, we said if y is equal to f over g, what was the quotient rule? G was squared on the bottom. I don't remember the top though. I always forget the order. F prime g? Minus F prime g.
Gx times f prime minus f times g prime.
All right, so that's good. I mean, I switched them, but it doesn't matter as long as we got there's an f prime and then a g on the first one, right? That's fine. So the derivative, I don't know, we'll call it y, I guess. I don't know what they call it. The derivative is going to require a chain rule. But during the chain rule, you're going to have a quotient. So the outside function is the square. They bring down the 2. Right, and you subtract by 1. Then you multiply by the derivative of the inside. So this is the part that's hard, or has a few extra steps, I guess. So I'm gonna put a quote to say we're doing that derivative next. Yeah. Okay, so deal with this derivative. We're gonna need this. Okay, so let's call this f and g. I had to put f g of x or f of x, but it's fine. It's implied. So this part I'm just gonna leave it alone. We're not gonna need it for a bit. So it's just a 2 times x cubed over x to the 6 plus 7 to the first, because we lost the power. Times this derivative would be a quotient rule. So g squared, right? Then we do f prime g, so f prime g minus g prime f. I ran out of space, sadly. Let me see if I can write a little smaller. So F prime times G minus F times G prime. Okay, so that is technically the derivative. That's the calculus step. Cool. So at this point, all we have to do is algebra. But any questions on this step?
Just the part the part that showed you there was gonna be chain rule was the fact that it was square.
Yeah, the chain rule was because, yeah, we had a square and an inner function. And then what during the quotient or during the chain, you had to do a quotient.
Square or the square root or cube root or anything like that automatically that it's going to be positive.
Pretty much. If there's some weird stuff inside of, then yeah. So notice how this is the same stuff, right? Being multiplied on the bottom. Do you agree that this times this is a cube? Right? X this times this piece is a cube of the same thing. So what I'm going to do, multiply the 2 right there. And then I'm going to leave that out here. I'm going to bring this inside.
What is that, a 2x what?
Cubed.
Oh, okay.
So cubed, right? Multiply this garbage. 3x squared times x6, 3x squared times 2. Is that a 2? No, that is a 7. I cannot read my own handwriting. Three x to the 8 plus 21x squared. So that's the first distribution. Minus 6x to the 8. I don't need all that over there. Cool. All right. I'll center this just because it looks weird, not that it matters. Okay. Combine like terms. And then distribute the 2x cubed inside, and that's pretty much all we can really do. Maybe something cancels, but I doubt it. Doubt it. So 3 minus 6 is a negative 3 plus the 21x squared. Do you see anything we can factor here?
X squared.
Yeah, x squared. What else? Could pull minus 3 out, I guess. So 2x. What's up?
I'm just wondering that would still give us a minus inside the parentheses.
Yeah, I mean, you don't have to pull out the.
Huh?
I pulled out the minus just because I wanted this one to be positive.
First, the leading term positive.
Yeah, it's just personal preference. It's not necessary.
So that's always an advantage for them.
Nah, not really. I'm hoping that it'll look like this. Because if it does, then we could cancel. That's another reason. If I pull out a -3, I would lose about 2 power and it becomes positive like this one. This becomes minus. Yeah, so almost the same, right? Almost. But not the same. And the question was plus at the beginning, right? On the bottom.
Yes.
Well, double check because if it feels like it's something should cancel, right? But see if there's any mistake anywhere. This minus is built in, and the formula was f prime g minus f g prime or g prime f g prime minus f prime g. No, I don't think it's gonna happen. Oh well, whatever. Does this become -6x to the 5th times x to the 6 minus 7 over x to the 6 plus 7 cubed. That's as pretty as you're gonna get. But notice that all these steps are just algebra, right? The calculus was right here. Right, all this first few lines is up to after this point, all this is algebra. So if you're good at algebra, this class won't be too bad. If you've forgotten it, then this class will be frustrating. But you'll have to learn it little by little, right? Painstaking, you're gonna be tortured by it, so it'll stick. Any steps that don't make sense? They're all right. Did you see how the chain rule can get kind of out of hand, right?
For me personally, it's like when you say things like it's composite, when there's something on the inside or something crazy on the inside.
Mhm.
When we were doing, inside automatically makes me think parentheses. You're talking about inside parentheses.
For the most part, yeah, but
We put parentheses as the product.
sure.
Trying to figure out a way to recognize it right away.
But the power rule had parentheses, but no powers.
Okay, it's the power.
Yeah. If there's a single power, there is no outside function. But if you see any other number, 2, 3, half, anything other than 1 in the parentheses, it's going to be a chain rule. Unless the inside is really simple, like a single x or something. Like
Oh, could we say that they were linear equations, I guess? There's not a power, right? It's just a linear equation. I'm thinking, oh no, some of the inside ones would have power.
yeah, so either the outside is a 1 or the inside is something really simple, like an x. Like if the outside is a cube, but the inside is a single x, well, that's not chain. Right. Right. Let's move on to 3.5. So this is when we pretty much have to let go of the prime stuff. You can kind of still use it here and there, but it starts to make more sense not to. Okay, so what you're gonna do is take the derivative. So find dy dx. X plus y squared equals to 5. So this is giving you a hint to take the derivative with respect to x and then solve for dy dx, what we're going to have to do. So what you do is take the derivative with respect to x. We're no longer doing, so we no longer have just one variable. We have two different ones. We're choosing to take the derivative with respect to a specific one on both sides. Okay. So have you guys taken linear algebra yet?
I'm gonna do that in the fall, but you're not teaching calculus too over the summer. Did you know that?
Not at the moment. They might give me one later. But right now I'm only doing a Maymester. They might give me one, give me a summer one later. We'll see. Who's teaching Cal 2 now? Do they have names on them?
Yeah, but I can't see it.
If it says unassigned, then they might give me one later. But if it already has a name, then maybe not.
Kennedy, Digio, One, Troutman, Brooks,
Brooks?
Brucks.
The J Brooks?
Yes, but it's J dot dot dot, so I don't know what the rest of it is. It won't let me like,
Is that at SAC?
yes.
Jay Brooks is a friend of mine. Used to be my tutor way back when. He's a good guy. But anyway, yeah, it looks like maybe not Cal 2 this summer. Okay. So when you're doing with respect to x and you have an x, you just do it like you always do, right? Like, for example, if you're taking a derivative of x squared, you would get 2x. Because they match, you don't do anything special or anything different. See what I'm saying? When I mean that you do the same business as usual, like we've been doing this last 6 sections. So derivative of x would be what? Right, so there's no number in front. This power would become 0, right? This is going to be a 1. So nothing special. Well, you know what? Let's make it more complicated. Let's put a 3 here. So what would be the derivative of x cubed?
3x squared.
All right, so business as usual. Now check this out. They do not match. So this is what they mean by implicit. Taking a derivative of something that is not with respect to the same variable is an implicit derivative. So I can't straight up just do it directly. You do it implicitly, and then you solve and try to isolate if possible. It's not always possible, but here we can, and we will. So what you do is you take the derivative as like normal, but then you tack on a chain rule because of the implicit piece. The derivative of y squared is 2y times dy dx. So because it's not with respect to the same thing, you have to add this piece. Okay. So that's the only difference. Is you do the same thing you usually do when you add on dy dx. Derivative of a constant is 0, so who cares? Does the idea make sense?
It got better when you added the cube onto it.
What's that?
It started making more sense when you added the cube to it.
Yeah, derivative of x, I mean, sometimes people forget. You bring the 1 down and subtract, right? Just in case you need this later. You would bring the 1 down and subtract by 1. Right? That's why it's a single 1. X to the 0 is 1. So anyway, this piece okay? So just solve for this piece and that's it. You're done. So I'm going to subtract that over with dy dx, 2y right there, right? Equals negative 3x squared. So I subtracted it over to this side. Then divide by 2y on both sides. So dy dx equals this. So we found the derivative. But it's implicit. Any question on this example? It's okay. We're gonna do a bunch of them, but you guys cool on this page? Okay. So I think this one, let me open the homework so make sure I delete the garbage. That's fine. Okay. So let's do number 1. It's almost the same. Find dy dx. So take the derivative with respect to x because dx is on the bottom. That's our hint. Both sides. If they would have said dx dy, you would do d dy of both sides. Okay, so derivative with respect to x of this term minus the derivative with respect to x of 7y squared. I left the minus out there. You could leave it in there if you want. Makes no difference. I just wanted to. Derivative of a constant is 0, no matter with respect to what variable we're talking about, always 0. So what is this derivative? Yeah, 6x. What is this one?
14.
14y, and then we have to tack on that piece. That's it. Now we solve for that piece. This makes sense so far?
Solve for x, we solve for dy.
Yeah, sorry, dy dx.
You have to put, or do you have to say the whole dy dx?
No, that's what, yeah, so we're finding dy dx. Dy over dx is the derivative of y with respect to x. That's what it's called. So when we start doing word problems in the next section, or the last section of chapter 3, these things are going to mean something. So like if you have, I don't know, it's a famous example. Let's say you had a balloon, you're pumping air in there. So you have a rate of the circumference, right, growing with the air going in. Then you have a rate of volume increasing inside the sphere or the balloon. So all those would be different dy dx's or dr dt, right? Change of radius over time. This means change in y over change in x. So all those ideas will start coming in. But it can be applied to really any kind of example. Anything that you're changing, moving, whatever, these start to pop up and they mean something. Does that make sense? So we'll see that in a little bit, probably Monday. Solve for dy dx. I'm going to move that 6x over and then divide by negative 14y, and we are done with this example.
So it'd be 6 over 14 since there's
It's going to be something. Reduces, right? So positive, that's for sure. 3x over 7y. So the basic idea makes sense before we move on. Do you see the pattern? Because they start to get weird once we start doing product, quotient, chain rule. So we throw all that stuff in with implicit at the same time. So this needs to make sense before we go there. You guys cool on example 2? Let's do one that has a product rule. This is problem 3, your homework. So find, oh, you wrote that. So x to the 4th, y to the 8th, minus y equal to x. So d dx of x to the 4, y 8th, minus d dx of negative y equals to d dx of x. So do you see what's gonna happen here? Right, we have a product.
Why is it negative one?
I wrote it twice. Sorry about
Oh,
that. Okay. So this will be a product rule. Formula says you take the derivative of the first one times the second one plus the derivative of the second piece times the first piece. Derivative of the y would simply be 1 dy dx. Derivative of x is 1. Okay, so I set up the product rule here. These first two terms. This one we did, and this one we did. Okay. Which one? This one is right here. All right, what's the derivative? Actually, the fourth.
4x.
Okay, so that part's done. Derivative of y to the 8th. So that has to be done implicitly. So the first part's the same, but then you multiply by dy dx. The derivative is done. So the process is get everything that doesn't have dy dx to the other side and then try to solve for it. So this term doesn't have one, but the rest do. So I'm gonna move that guy over here. Let me get 8y7 dy dx minus dy dx equals to 1 minus 4x cubed y8. So factor dy dx out of here so you can divide the rest out. So divide this on both sides and we're done. So dy dx is equal to 1 minus 4x cubed y8 over 8y7 minus 1. So you see, once the derivatives get a little more complicated, it starts to get more involved and a little messy, I guess. Do you see what happened at the beginning or in the middle? You see that this triggered the product rule here, right?
equal to 1, and I thought it was supposed to be equal to 0. Or did I miss something?
There was an x on the right side.
Oh, okay.
Derivative of x would be 1. The last two, I think, had a number there. So it went to 0. Doesn't have to.
Okay, so it's whatever that's whatever the derivative.
Yeah, we're doing derivative of both sides, not just the one side.
So I remember at the beginning, I remember when you said that we were.
Yeah, because it's hard to distinguish, like, is it prime for dy or dx or dt or dr? So we start getting away from it, because when we get to the word problems, it's going to be with respect to something specific. Could be radius, could be distance, could be speed, could be an angle. I don't know. Depends. You could technically still do it here, but we should start getting used to it.
So the only reason it doesn't take the derivative of the y to the 8th is because there's not a y in the d over dx, right?
One more time? Like, what do you mean?
Of the third line.
Here?
No, that's one. So the d dx in front of the x to the 4th, y to the 8th.
Mhm.
The reason it doesn't take the derivative of the y to the 8th is because there's no y in the d dx, right?
Well, we do it over here. So this is saying take derivative of this term, and these two, I went ahead and did it. So it happens there. So derivative of y to the 8th is 8y7. Then the implicit piece comes out times dy dx. And that guy's still here. Well, that implicit happens because it doesn't have a dy there. If it did, you would just put 8y7 and that's it. Nothing else would appear. Any other questions? Does the up to, so right here, the derivative is done. The rest is solving for dy dx. All right, you guys cool on this page then? So x e to the y minus 11x plus 7y equals 0. Okay. So you take the derivative of each piece here. So you start. Both sides. Although the right side you can see it doesn't matter, right? It's already 0. So this has a y on it. So this is going to be a product rule, but during the product we have a implicit. The derivative of the first times the second plus the derivative of the second times the first. So that's the product rule right here. What is the derivative of 11x? Yeah, it's going to be 11, right? Derivative of 7y. Yeah. So there's the derivative for the most part. We just got to take care of this piece here. Derivative of x is the 1, right? So plus the derivative of that is itself. But then you got to tack on that piece. Equal to 0, forgot. All right, so at this point, the derivative is done. Isolate these two, move this garbage over. We will have EY dy dx plus 7 dy dx equal to e to the y, actually, minus plus 11. Move the 11 over, move this guy over.
By X, right?
What's that? Oh, the x, right? Should be an x on this one. Put it in the front. Okay, so factor dy dx. We'll be left with x e to the y plus 7. Divide this garbage out and we are done. This is gone. So dy dx is equal to this.
That's where you'll get tempted to try and take out the 8.
You can only cancel if you can factor it. Yeah, if you can factor it out from top and bottom, feel free to cancel.
Respect is always at the bottom.
Yeah. Any questions on problem? Example 4. Okay. Let's do one with a chain rule. So y is equal to sine x, y. So what's the outside function and inside function?
Is there a particular number for this one? On homework?
I think I might have made this one up.
It's number 8.
Let me check that. Oh, it is? Oh, yeah, it is. Cool. All right, let me write that down. So what's the outside function?
Sine X.
On the inside? You see how the inside is the argument, right? X, Y. So the right side is just dy dx. I did the hard part for you. The left side, right? So derivative outside, what's derivative of sine? Do you guys remember? Derivative of the outside sine,
Negative cosine.
regular cosine. So you do the outside and keep the inside the same like we've been doing, but then you multiply by chain rule. Derivative of the inside. Yeah, so there will be, there's going to be a product rule that's implicit during the chain rule. So sounds annoying. The derivative of the x times the y plus derivative of the y times the x. All of this is in here. This part's done. Who cares? So derivative of x will be 1 times the y plus derivative of y will be dy dx times x. Multiply the cosine in on the next step. So cosine times that guy would be y cosine xy plus cosine times that thing would be x dy dx cosine xy. Up to this point, you guys okay? Does it make sense? So the derivative is done at this point. Move this guy over here, isolate dy dx. So minus x dy dx cosine x y equals y cosine x y. Factor dy dx like usual. And then we'll just divide the leftover, right? So 1 minus x cosine x y. So divide it. So this is gone. So our solution will be this stuff. Okay, so let's look at it one more time. We had a sine outer function and the inner function was a product. So that was a chain rule that then triggered a product rule. The derivative of both sides gave me this guy and then chain. Derivative of the outside is cosine times the derivative of the inside. This is the chain rule happening. Derivative of this right here is this product rule there. Actually taking the derivatives happens here for the product. After that, we just do algebra to solve for dy dx. So we multiply this out, get these, move this guy over here, and then factor dy dx, divide this garbage, and we solve for dy dx. Any steps that don't make sense?
dy dx is coming from. So dx times y times x. Then you end up with dy dx.
Yeah, derivative of
Because you have to have the y.
think of it as two ways you can think about it. They just kind of multiply together, or derivative of y is 1 times dy dx. So 1 times that is just that. Right.
So whatever makes it dy dx.
So you just do the derivative like normal, and then you tack on dy dx. I think that's the easiest way to think about it. So if it was a y squared, it'd be 2y and dy dx. Derivative of y is 1. dy dx.
Oh,
Okay. That's pretty much it for 3.5. It's going to keep repeating itself. The derivatives might be a little harder. Let me get rid of this guy. Related rates is a little challenging. So I'm going to say that for next time. You guys have any homework problems that you're stuck on or anything? Because related rates is one thing but word problems, and they're going to assume you know everything before, and you're good at implicit, but we just started implicit. So I don't think it's a good idea just yet.
be a really, really dumb question, but what's the little triangle?
Delta x. Think of that triangle x here.
There's like, I don't know. Don't mind the bubbles. I got mad at it. I took the screen protector off.
Oh, it'd be double on it.
Yeah. Spicy.
Derivative.
What number is that?
3.1.
So I guess simplify everything. Here that they're doing. Go to first. Fine. So let me write it down. Yeah. 3.1, right?
Yes, sir. I remember doing something with the little triangle in algebra, but I taught myself algebra this past time. Not a lot of good stuff this time.
Watch. Watch it out. I just saw that. Watch it.
For C, try the number 2. Just curious. Okay. Let's see what happens. So 9 minus 8 is 1, minus 1 is 0, so we're left with negative 4 delta x over delta x, which cancels, right? So the limit no longer has any variable, so that would just be negative 4. There's no more delta x. So I would say f of x is equal to negative 4x. The derivative is equal to negative 4, right? That's what I'm understanding. So I'm working backwards. They told me that this was the derivative, right, in your problem. So we found it. So that means f prime is that. This would have to be f. Thinking C is, did it work too? I was thinking, but let's see how they approach it.
All except for FX.
What was the number again?
3.1
11.
Recording right now, so
Yeah. So 2 is right. Your numbers are different, right? Okay.
Nice.
Oh, I see it. Okay. So basically, this right here is my x plus h when we did it on paper, the long way derivative. So they're plugging in a number for x. So that's your c. So this number right here is c. So the function f would be 9 minus 4x.
yes, that.
So this is the function, 9 minus 4, x is the input. So this would be our function. C would be 2. So F prime would be what we found earlier.
So the little triangle really didn't have anything to do with this, just kind of there to throw me off.
They're using that as a notation to stand in for H. What they mean is change in X. That's what the delta means, the triangle. Triangle is capital delta. And it's supposed to signify change in X. But I don't like writing delta X because it looks weird and confusing. So I try to stick to the H. So what they're really doing is they're doing H approaches 0 of f of x f of 2 plus h minus this 1. It's like an alternate approach. F, oh, hold on. F. No. There's a reason why there's a 1 there. There we go. So the original formula, right? So this ends up being, using the notation we did in class, this ends up being 9 minus 4 times 2 plus h minus, so there you're plugging in the 2 right there. This is the steps that did not show. F of 2, 9 minus 4 times 2 is a 1, right? If you plug in 2, you're going to get 1. That's where their 1 came from. So you get 9 minus 4 times 2 plus h minus 1. So that's how they got here. Okay, does that make more sense?
Yes.
So just replace h with delta x, and that's what they got. They just used a different notation. Yeah, that question is a little odd, but you basically have to look at it and see, okay, what is the f of x plus h, and what is the c that's going in there?
If I go back and look at 3.1, it'll say that the C is always in that spot.
The c will always be this guy. No.
Oh, yeah.
Yeah. Because this is x plus h, but x is being replaced by c. Do you have any other questions? Thanks. It's like Russia's started the invasion. It's cool. It's crazy. You guys have any other homework questions? I will spend this weekend catching up if you can, and bring a bunch for Monday. So Monday we'll just do word problems, and then we'll do some homework problems. And if not, we'll do 2 sections if you don't have questions. Right, stuff here, guys.